All right, this lesson is on operations of functions where we're going to add, subtract, multiply, and divide. You can perform operations of functions the same way that you can perform operations on numbers of expressions. So this chart shows you the notation for these operations of adding, subtracting, multiplying, and dividing. Our first example here has a quadratic function and a linear function, and we're going to go ahead and add and subtract these functions. So the first one is saying we want to add f plus g. So we're going to take f of x plus g of x. So we're going to replace 4x squared plus 3x minus 1 plus 6x plus 2. So we get our two polynomials that we're going to combine together. So we're going to go ahead and just drop those parentheses. And then put it in standard form and combine any like terms. So we have like terms with 3x and 6x, which is 9x. And then like terms with our constants, negative 1 plus 2 is 1. Our second example, we're going to subtract the function f and g. So we get f of x minus g of x. So it'll be 4x squared plus 3x minus 1 minus 6x plus 2. Now you want to be very careful in this next step. We have to distribute that negative all the way through that binomial. So we're going to drop the first parentheses of that quadratic and then subtract all the way through that binomial. And now put it into standard form. So our first term is the quadratic. Combine like terms, 3x minus 6x is negative 3x. And then the constants, negative 1 minus 2 is negative 3. Here's our second example. A linear and a quadratic. And we're going to go ahead and add and subtract. So we're going to take f of x plus g of x. So f of x is our linear. G of x is our quadratic. We're going to go ahead and drop the parentheses. And now put it into standard form. So our first term is our quadratic term, x squared. Then positive 5x and negative 5x cancel out. Negative 6x and positive 6x cancel out. So you're just left with x squared. The second example, we're going to subtract f of x minus g of x. So f of x is our linear minus g of x, our quadratic. Now again, just like the last problem, make sure you distribute all the way through that trinomial. So drop the first parentheses and then change all of those signs in that trinomial. So you get a negative, a positive, and a negative. Now put it into standard form. So negative x squared, positive 5x and positive 5x combined to positive 10x. oops, I see a mistake here. This should be just 6 there. And then -6 and -6 will become -12. All right, now we're going to go ahead and multiply and divide in this next example. Be careful when you divide that you need to make sure you do your domain restrictions. So we have a quadratic and a linear. In our first, we want to multiply g of x times f of x. So we have 2x squared plus 4x minus 6 times 2x minus 2. So we're going to multiply, wrong order, 2x minus 2 first, then our f of x. All right, so we're going to multiply those two polynomials together. So we're going to distribute. So when we do that, we're going to multiply the 2x into all three terms. So we get 2x times 2x squared is 4x cubed. 2x times 4x is 8x squared. 2x times -6 is -12x. So there's the distribution of 2x. Now we have to distribute the -2. So we get -2 times 2x squared is -4x squared. -2 times 4x, -8x. -2 times -6 is +12. Now we want to put it into standard form. So our first term is our cubic, 4x cubed. Then we have like terms with the quadratic terms. So that will become 4x squared. Then we have like terms with our linears. They will combine as -20x. And then our constant of 12. Our second problem now says divide. F of x divided by g of x. So we're going to take 2x squared plus 4x squared minus 6 divided by 2x minus 2. When we do these, we want to make sure if we have any factoring, we have to do that first and see if we have any common factors. So in the numerator, we have a GCF. So we're going to take out the GCF in the numerator. So we're left with x squared plus 2x squared minus 3. In the denominator, we also have a GCF of 2. Back up in the numerator, oops, I have a little mistake here. This should just be a 1 there. Now we are going to do the diamond up in the numerator. So we say, what are the factors of -3 that add to +2? So the factors of -3 that add to +2 are +3 and -1. So we have 2x plus 3, quantity x minus 1. In the denominator, We have that 2x minus 1. All right, now the problem has been factored. Now we look for those common factors. So we see we have a common factor of the 2, so those will cancel. We have another common factor of the x minus 1's. So our answer will be x plus 3. So there's our answer. And then if we look back up here, it says we have to identify any domain restriction. So what does x not equal? So if we look here, what do we not want x to be right there? We don't want that x to be a 1, or that'll make it undefined. All right, here's our last example. We want to multiply f of x times g of x. So x plus 2 times x squared minus 4. So we're going to FOIL out distribute. So first we get x cubed outside, negative 4x inside, 2x squared, last, minus 8. Then we're going to put it into standard form. X cubed plus 2x squared minus 4x minus 8. Second operation, we're going to divide f of x divided by g of x. So we substitute f of x in, which is x plus 2, g of x, which is x squared, minus 4. We have to do any factoring. The numerator, there's nothing to factor. The denominator, we're going to do the difference of 2 squares. X plus 2, quantity, x minus 2. We look for any common factors. There is a common factor. X plus 2 and x plus 2. Now be very careful. There's a 1 there and a 1 there. So what's left? A 1 in the numerator divided by x minus 2 in the denominator. Now, just like the last problem, we do need to identify the domain restrictions. So we don't want this to be a negative 2, and we don't want that to be a positive 2, because those will make it undefined. So domain restrictions will be x cannot be 2 and negative 2.